Hello, everyone. Actually, I'm going to start a timer so I kind of know where I am. Okay, hello, everyone. Today I'll be talking about some history of the web system of literate programming, which is what TeX and Metafont are written in. And we'll also look at other possible directions for literate programming systems. This is part of a project that will very soon be published as a book from the TeX users group entitled Pre-Literate Programming, Writings and Interviews. This book is an anthology of precursors to Donald Knuth's literate programming, as well as interviews with Knuth and his students at that time, and a few other bits. So this proof copy arrived at Carl's door on Wednesday, so it's hot off the press. And I'll send it around for show and tell. But first, Eric emphasized yesterday that he is not a bookworm, so please just skip Eric when it's passed around. The cover here depicts Hugo, a medieval monk, scratching out a scribal mistake in his structured program. I just want to note that the book is not yet on sale. That will be in a few weeks, give or take. But here's the link right here for that eventuality.
Nothing there yet.
There, yes, it is TK, yeah, to come. This anthology project began with tracking down Pierre-Arnoul de Marneffe's 1973 report on a system he called holon programming, which is shown here, the title page to Holon Programming, a Survey, which Donald Knuth cites as a primary influence on web. This report was privately circulated and for a time seemed to be lost to history, but was recently made publicly available. And we'll talk more about de Marneffe's vision soon, but there are many more influences on web than just de Marneffe. So this is the first page of Knuth's 1981 handwritten draft of web, which was initially called doc, short for documentation. And web, along with much of Knuth's other works, was composed on this extra long legal paper from a Canadian manufacturer. And in the interview in the anthology, Knuth gives the specifications of this paper. He says, quote, "It's 8.5 inches wide and 14 inches high, thus legal size, with ruled lines about 5 millimeters apart. I still use it to write The Art of Computer Programming, but my supply is running out. I've asked my sister, who is a Canadian citizen, to see if she can get me some more, but she hasn't been successful," end quote. So if anyone in the audience or listening out there knows where in Canada this paper is made, please let Knuth know. If we zoom in on this draft, well, Knuth's handwriting isn't the easiest to read, but if you squint, you can maybe make out the sentence, quote, "It is impossible to list all the related work that has influenced the design of doc, but the key contributions should be mentioned here." And so here is a list of authors and interviewees included in the anthology, many of the names coming from Knuth's initial list. Some of these names are well known to many, like Edsger Dijkstra and Nicholas Wirth, and others are deep cuts whose pieces are being published for the first time. But of course, the list of influences goes on, and I couldn't include everything. So permit me to just mention here two fossils from the days before web. Here on the left is a page from the 1914 natural language algorithm from Leonardo Torres Quevedo, a Spanish engineer and inventor. And this algorithm describes a chess-playing automaton, a very early one. And on the right is Peter Nauer's 1962 ALGOL compiler documentation. Nauer's documentation and his command of English was just amazing. But even though we couldn't include everything, the anthology includes pointers to many of these old influences. So in editing this book, I looked at different embryonic specimens whose parts can now be discerned in web. So tracking literate programming in its early stages led to the question, what other forms could it take? But before discussing possible varieties of literate programming, I should distinguish literate systems from non-literate ones. I'm calling a literate system one that allows the programmer to mix source code snippets with natural language, together with the ability to permute pieces of the program text. So this is a very, very rough taxonomy, but it allows us to distinguish something like Jupyter notebooks on the left here as non-literate, as they don't allow code reordering. You need to execute one cell after the other. And org babel mode in GNU Emacs as literate, because in org babel you can use a no-web-like markup that lets you permute your code. Both are quite similar to each other, as both allow prose and figures to go alongside the source code, but there is something essential in this ability to permute code. Knuth calls systems that don't allow reordering, quote-unquote, zeroth order literate programming. So there are many literate systems out there, because a literate programmer's favorite thing is to make their own framework. And so here are just some of them. There are hundreds on GitHub if you look. But even with the previous broad definition of literate programming, they all look and function pretty much exactly like web, okay? So as Taco Hookwater writes, there are some differences between all these literate programming systems, but overall, they're all something like 95 to 99% compatible with each other. But spiders weave all sorts of webs. There are sheet webs, triangular webs, tangle webs, orb webs, funnel webs, and more. So today we're going to try to dream up some new webs of our own. One interviewee for the anthology was David Fuchs, to whom Tech the Program was dedicated. And so here is Fuchs, depicted in medieval monk clothing. Specifically, the wardrobe is from 12th century French manuscript. And in the interview, Fuchs talks about running Tech 78 on 36-bit machines and deciphering poorly printed Pascal user reports. But at one point, he digresses into the future and speculates on other possible directions web could take. He says, I always wondered if one could design a literate programming language from the ground up that would be directly compilable with no Tangle equivalent needed. And just to clarify, Tangle is a program that takes a web program and converts it to pure Pascal, which hopefully compiles successfully to give you an executable. And so this two-step process is very much a part of web, both with Tangle and its companion program Weave. And then Fuchs goes on to list some desirable features of this system. There would be no textual substitution macros, which he notes were just put into web as a way to get around Pascal's limitations. The compiler would decide if the modules or sections would be inlined directly or would be wrapped in a procedure. And this future language wouldn't feel like two languages bolted together by a third, like Pascal and Tech bolted together with web, but would be one integrated language with only one set of rules to remember. But wait, what's past is prologue, and de Marneffe dreamt up this kind of integrated system before web even came onto the scene. So again, this is the title page we saw earlier to the Holon Programming Survey from 1973. And this work came out of the structured programming debates. And Belgian computer scientist Pierre-Arnoul de Marneffe wondered if a language could be built so that structured design was a property woven into the language itself, rather than a discipline imposed by the programmer's own diligence. So he designed the Holon programming language, with one of the goals being that the programmer can present the program in mostly natural language, in the same order that the design decisions were made. So the kind of design de Marneffe imagined was a pure top-down design, where each task could be represented by a hierarchic tree, and with tasks broken into subtasks. And here he was very much influenced by Dijkstra's ideas of semantic layering that Pavneet mentioned this morning. So for example, if your task is to get a drink of water, this can be decomposed into smaller tasks. Find the water, find a cup, fill the cup, and drink it up. So the basic unit would be the holon, borrowed from Arthur Koestler's word for something both whole in itself and part of something larger. So that quote is actually Koestler's, not de Marneffe's, that's my bad. The idea was that a program should be decomposed into small self-contained sections, each written largely in natural language, and each nested inside other holons, forming a hierarchy of holes within holes. So some of the early structured programming proposals expected the programmer to translate a structured design written in kind of a pseudo-language into a program written in a conventional language, and they expected that translation to be done by hand. But de Marneffe noted that this translation step is non-trivial and quite error-prone, and he thought that the programmer should be using the same language for the design and the implementation of a program. Namely, just like Fuchs, he wanted to make the design language compiled directly to an executable. So here is part of a holon program from the 1973 report. And the program originates from Dijkstra's Notes on Structured Programming, one of his later revisions to it. And the details aren't important here, but you'll see it's mostly natural language description with the algol-like code given here between the # delimiters. And then the compiler would transform the holon program into what is eventually an executable. So on the right, de Marneffe shows a legal algol program here, which for de Marneffe was only supposed to be an intermediate form in his compilation process, but which Knuth saw and envisioned as the actual output of tangle. And we can see the similarity between de Marneffe's holon on the left and an equivalent module written in Knuth's web here on the right. But the two aren't entirely the same, and there are actually quite a few differences in de Marneffe's report. One is that with holons, scope mostly follows from a holon's place in the holon tree, so that a variable declared in an outer holon is visible to everything nested inside it, but it is not visible to the sibling nodes, so these nodes at the bottom that share a parent. And this is not the case with web. That's not how the scoping works. Another difference is that there were sophisticated compilation techniques planned where holons would become either inline code or they would be wrapped in procedures based on a number of factors, very similar to Fuchs's sketch for a new literate programming language. But unfortunately, de Marneffe's planned language was never implemented. It was a huge project that he had envisioned with all kinds of extra bells and whistles, and this was for a very quick dissertation done in France, which is a very short time that they allot for dissertations to be completed. And so holons would remain a part of a language existing only on paper. That is, until a recent literate programming tool resuscitated the term, which brings us to our next character, Graham Nelson. Nelson is a mathematician, he's a poet and a writer, and he created InWeb, which is a fully literate literate programming tool. I don't have a picture of Nelson, so I couldn't turn him into a monk, but using InWeb, he wrote one of the largest literate programs to date, which is an interactive fiction programming language called Inform. It's now Inform 7. And he's also written a number of very influential interactive fiction works, including Curses from 1993. And this is a slight aside, but one of the original interactive fiction games was Colossal Cave Adventure, which many of you have probably heard of. And it's a beloved program of Nelson, Knuth, and many others. And Knuth rewrote, actually a rewrite of Adventure as a literate program, which you can find in his selected papers on fun and games, book, or on his webpage, there's an updated version of that. So I just have to recommend this paper by Dennis Gerrard. That's a great historical dive into the original adventure code and the spelunking that went along with it. So check that out. But let's get back to Nelson. The anthology project brought me into contact with him, and I was amazed to see this in the latest update to his tool. InWeb includes holons. So here, a holon is just like a section or chunk in one of the typical web systems, except that a holon is a language construct with semantic meaning, rather than being an unchecked macro substitution. And so this came out of Nelson using CWeb for a number of years and running into a number of problems. And so one of the problems had to do with, this is an email exchange from Nelson, one of the problems had to do with polluted variable namespaces and being unclear on what exactly each variable's scope is. And I really like his droll CWeb module title here. There are many advantages to treating holon as language construct, including, so it depends on what your base programming language is here. There are ways to say, I'm using Python, I'm using a C-like language, etc. I'm not going to go into the details. But some of the advantages include correctly inserting block delimiters, such as braces or begin-end pairs, avoiding the dangling else ambiguity, and preserving indentation for whitespace sensitive languages like Python or Haskell. And I just want to note that this last item had been previously solved by other literate programmers, such as Norman Ramsey in his NoWeb, and he just passes the code chunks straight through to solve this problem. So check out Graham Nelson's InWeb, which even has a notation mechanism that allows you to transform a well-commented non-literate program into a typeset booklet that you can read by the fire. Or, as Frank mentioned yesterday, you can even take some of the pre-LaTeX 209 class files that are brilliant if you want to be an archaeologist. So those two can be beautifully transformed. But Graham Nelson was not the first person to run into problems from the fact that web modules are simple macro replacements. So let's go back to a 1981 Tugboat article where Knuth details some of his first experiences with web. In this article, he lists 8 bugs he found while writing glue.web, or as Dijkstra would say, that he inserted into glue.web. And so one of these bugs is due to accidentally forgetting Pascal's begin and end delimiters. And then later in his 1987 Stanford class on mathematical writing, he mentions quote-unquote appalling bugs that will occur if you, the web programmer, do not adopt the habit of putting your begins and ends inside the called modules and not putting them in the calling module. In his interview in the anthology, he cites monthly bugs in his CWeb programs due to clobbering a value from a variable used in another module. Well, each of these problems Knuth mentions are exactly the kinds of errors that Graham Nelson's holons prevent. So why then did Knuth not place language features into web and CWeb that would solve these scoping issues? Or why not create a more unified language? Then only one set of rules needs to be remembered, rather than the rules to web, Pascal, and TeX, as well as the interactions between each of these three. Well, one answer comes from Knuth's 1974 letter to de Marneffe, and a snippet is shown here. Knuth encourages de Marneffe to implement the holon programming language before saying, I myself must get on with the writing of volume 4 of my series, so I have little energy to devote to the development of languages. Of course, he would go on to develop some more languages, but at that time, Knuth had already designed a few languages, and he knew that implementing de Marneffe's entire ideas would be extremely time-intensive. So Knuth knows that the interaction rules in web can bite you, but it's a system that has worked well enough for decades. He says, I use CWeb knowing that it was a quick and dirty implementation, but it still does almost everything that I want, exactly as I want. And again, from his mathematical writing course, he says, quote, now of course, if I had a programming system, if web were not being patched on top of Pascal, and I was really using a programming environment, my programming environment would do this for me. It would make sure that I wouldn't make such errors. And here he's referring to the begin and end delimiters, end quote. So of course, Knuth made web as an experiment used to implement tech and metafont, and more importantly, to present them to other humans to read. He says that web is just a demonstration of what could be done. So for anyone implementing a new literate system, go ahead and try adding some of de Marneffe's ideas. So add parameters to the chunks or sections, and then give them algol W's for different possibilities of parameter passing. Or you can take from Peter Nauer and add an explicit cluster construct scoped around a stated invariant, and then checked at cluster boundaries. So go crazy, experiment, and spin some new webs. Many people have been indispensable throughout this project, so thanks so much to everyone on this list, and to Sophia, who shouldn't be missing from this list, and especially thanks to Andreas Scherer for reading the quote-unquote final proof. Andreas was very meticulous in his notes. So Andreas is the main maintainer of CWeb right now, and Andreas even pointed out an incorrect math equation from a classic Nicholas Wirth paper that had slipped by the communications of the ACM editors. And he had many other notes like this, so thank you, Andreas. But of course, the biggest thanks go to Barbara and Carl, who proposed the project. They read everything, and sometimes read everything multiple times. They patiently edited my insistence on a back of book index, and they gave the best suggestions and support. It's been a ton of fun collaborating with you two, so let's make some more books. Thank you.
Thanks, Mitchell, for this really great talk. Nice. It's always a fun listening to you.
Thanks.
I enjoyed the other talk from 2024 very much this morning, so yeah, thanks a lot. So, are there any questions for Mitchell? Boris, do you have some? None? Okay, thanks a lot.
Thank you.
So I will hand over the mic to Carl Berry, I think, for the general